Good morning. Welcome to Denver, Colorado. I'm glad that every one of you were able to join us today for the inaugural Elevate event, Elevate 2017. If I could, I'll take a few moments. First of all, my name is Jarrod Siket. I'm the Chief Marketing Officer at Napatech, and we're very glad that all of you were able to be here. I've got a few logistical items for everyone. They just brought up some coffee, so please make yourself at home as needed. We have a jam-packed agenda today with some great speakers. They're going to share their experiences with you along the day. I'll begin by just telling you a little bit about Elevate. What is it and why did we choose to do this today? The goal was to make it a user conference for you. When we think about the things that are going on in the industry, the technology change, the evolution, what you're going to see through the end of these presentations, kind of cutting to the end, there are a lot of people now using FPGA-based technologies in their standard servers, in their appliances, all for the purposes of making their applications better on some dimension. So we wanted today to be, vendor-free, just users. We're happy to sponsor the event, but at the same time, you're not going to see any pitches from us, any product sales. This is simply about people sharing the experience, what they've done, what problems they faced in their application, be it network, security, analytics, you name it across the board, how they solved that problem and what product they were able to build and solve it for themselves in their own internal network or one of their end customers. So the goal here was folks that have been down the road before, share their experiences, both good and bad. Very short sessions. I think most of the slots are 40 or 50 minutes, so we won't get dragged into a lengthy presentation much more than that. We've got some market education, sharing some of that knowledge. But most importantly, it's to give an opportunity for all of you guys to be in the room together. That peer networking and learning from each other's successes and failures. But at the end of the day, what you're going to find is that in each one of these cases, the common thread is that FPGAs in some way have made their application, their service, their network better. So I've seen most of the presentations. They're very good presentations. I can't wait to watch them here live and hear the questions. With that, we'll begin. I'm first on the agenda, and it was just to set the stage to put the different set of companies and presentations all into context. When we look at the things that are happening in the industry right now, there are three major trends that we focus on here at Napatech: the world of cloud computing, 5G mobile, and the Internet of Things. They're very different networks, very different services, but the one thing they share in common is hyperscale. And in the cloud world, the hyperscale comes from the dissemination of thousands and millions and hundreds of thousands of servers to those endpoints. In the 5G world, it's a massive escalation of the endpoints. So no longer do we have these towers every couple miles down the highway. Now we've got 5G, access points in just about everything. Office buildings, old telephone booths, you name it, there's an access point. So it's a massive scale. And then finally, the Internet of Things. This is simply everything connected. Cars, automobiles, appliances, parcels in the mail, you name it, everything online. So again, it's a massive scale. And so it's that common thread of hyperscale that is changing the way that people need to build their networks. I don't know what came first, the chicken or the egg. In this case, when we talk about the deployment of standard computing platforms or servers as a now dominant piece of networking equipment. I don't know what happened first, but when I look at those three networks, cloud, 5G, and IoT, I think it was the cloud that sparked the revolution. And what we have now are more and more servers deployed in these hyperscale type of network designs. And given that that's where the servers are, that's where the workloads are. The applications and the services are following those servers. And as a result, the cost per hour, cost per watt, cost per bit, cost per pick your dimension of a standard computing platform is dropping through the floor. And so the consequence now is that we now have standard, high-volume, commodity server platforms able to be used for all forms of network and security applications that previously required big custom hardware. Now, with that spark of that revolution around that standard computing platform and the need to get to hyperscale, we've seen folks build networks in very different ways than many of us grew up doing ourselves. And we tend to focus on 4 or 5 dimensions. The first is performance. I think that tends to be immutable in networking. 1, 10 moves on to 25, 50, 40, 100 gigabit. The scale of the innovation. So this is software defined, agility, the ability to make that standard computing platform hardware live and evolve at the speed of software innovation. So here we're talking about software-defined networking, programmability, longer than typical silicon evolution cycles. The hyperscale economics, when you're talking about millions and millions and potentially billions of endpoints, when you're going to put these computing locations out there, you can't do it the same way. It can't be a $400,000 firewall. It needs to be anchored around this standard high volume and their implied low cost computing platform. And then the last two, security and orchestration. When you're talking about fanning out these networks to this hyperscale, you have to secure it in a way that's even better than the way we've done it in the past. Gone are the days of a perimeter or a perimeter firewall when everything is an edge, everything is a way for the bad guys to get in. And lastly, the orchestration. You simply can't, budget. We're going to, have an IT department person come in, rack that thing up, and spend, so many man hours, if you will, on every individual device. There's got to be a whole new way to manage and operate these hyperscale networks. So it's really those 5 dimensions of hyperscale that have led to a whole vast array of new technologies that I'm certain will keep all of us gainfully employed for the next couple decades. And this is where you see software-defined networking, server virtualization, network virtualization, network functions virtualization, open compute, open stack, open everything. If I were building a toaster today, it would be an SDN open toaster as a way to gain market share. So the networks are transforming. And as a consequence, the kind of devices, when you put this all together, the devices that people are using to build those networks are changing. In many cases, we see a shift away from these very large, custom vertically integrated systems. Now, they're not gone. They are absolutely there. They're an option. They're needed in certain places of networks. But we see new places for these open and standard platforms. And you can see them in 2 ways. A traditional appliance, in many ways, has evolved to be just a standard x86 computing platform with slight customizations on the outside to make it appliance. Or, in many other cases, just standard high-volume servers running software instances of those same applications. And that's where this notion of FPGAs come in. When we look at those standard computing platforms, many of your experiences in this room, I'm sure we'll hear and have them shared today, they suffer on some dimension. It could be performance, throughput, number of sessions, number of flows, the amount of security signatures I have. Maybe it's something as simple as just the amount of cores that I can physically purchase in a cost-effective manner in a standard computing platform. So for years, people have been looking at ways to accelerate those standard computing platforms. And out of the gate, people use standard NICs. In Intel, I think most people start with a standard Intel chipset. And as a data point, I think the window between Intel's Niantic, which was their 10 gig solution, and their Fortville, which was their 40 gig solution, was about 7 years. So right away, that doesn't fit our view of solving the requirement of software-defined hardware at the speed of software innovation. It's just too long. Along the way, there have been proprietary CPUs. Companies like, I'm trying to think of the food chain here, maybe Tylera, to EasyChip, to Mellanox, if I've got that right. But there have always been companies who have built in proprietary CPU technologies. And I think the issue there is simply proprietary. When you get into proprietary, you're losing the notion of an open system, standard tools, and ways to take advantage of those technologies. We've got multi-core MIPS options, so that's great. That's an open and standard processing architecture. But products like that, again, not optimized for the task at hand of making networking and security tasks better, can be inefficient. We see other things around network processors and other ASIC technologies. Again, closed systems that don't move at the speed of software innovation. So I'll tell you, as probably as recently as 5 years ago, if you walked into any one of your companies and said, hey, we've got a way to make your application run better, whether you're an OEM network designer or a large hyperscale cloud operator or an end user who wants to roll their own or do it themselves at home, if we walked into that room and told you about a technology called an FPGA that can solve it, a lot of people's eyes would have glossed over and ran away from the conversation quickly. But what we found over the past 5 years is that momentum has shifted. Given those requirements of hyperscale performance, innovation, economics, scale, security, and orchestration, we now have a lot of people gravitating towards the use of the FPGA. And I recognize that my title here says marketing officer, so that doesn't carry a lot of weight in a lot of meetings, but I can point to some external activities that validate it. You look at places like Microsoft Azure that have published seminal papers around 10 use cases of the different applications and services that they deliver that are now better or enhanced on some dimension based on FPGA technology. We've seen Intel go out in the single largest acquisition in the history of that company, purchase Altera, a leading FPGA manufacturer. What's interesting about that is not that it was their largest acquisition, it's that Intel is the world's largest manufacturer of standard NICs. So the fact that they're bringing FPGA into their family as a way to offer an alternative to a standard NIC in their devices is very interesting. And then a third example is if you look at like Amazon EC2, they now offer FPGAs as a service. I mean, that to me, that's staggering from the 5-year history. You can go to Amazon today, rent a server, rent a VM, and say, I would absolutely like to make sure that that one has an FPGA in it and have access to it, have all the tools. And I'm guessing some of our presenters from Xilinx today will tell us more about that. So it's very interesting times that we live in. And so we've given this a term. The industry has begun to call this reconfigurable computing. And it's just a notion of taking a standard computing platform and making it smarter on some dimension, making it reconfigurable. And I took the classic easy way out and cited Wikipedia there because it was convenient, and the fact that they referenced FPGAs as a popular way to do it. But by design, an intentional cocktail napkin-looking drawing, if this is a standard computing platform of CPUs, cores that are augmented in either VMs or containers, running an operating system, it's got disk drive, memory, storage, power cord, memory, but it's typically running an application, some commercial application, a firewall, a load balancer, or an open source equivalent. When we talk about reconfigurable computing, we're simply saying where are the places inside of that standard computing platform that struggle, that limit the performance of that application. And typically it's in the CPU or the networking side. And now what we're able to do with FPGAs technologies embedded in these systems is offload the workloads that are most punitive to the performance of those CPU cores and return those cores to the application or service that it was there to generate the revenue for. So what makes these times exciting for all of us in this room is there are now a large number of end users who are doing things in their daily business operation who can benefit from this notion of converting their standard computing platforms to reconfigurable computing platforms. And it spans a wide range from the big hyperscale cloud operators to their smaller cousins, service providers of all types in telco and cable in their rush to NFV-like architectures, enterprises now. Some call it enterprise NFP, just some call it virtualization, but there are a ton of applications that can run better on a standard server when they are accelerated. And then a myriad of government and defense network types and operators who in many ways look like enterprises, running the same applications just within a different framework of missions. But reconfigurable computing is helpful to all of these folks. And it's not just for 1 or 2 applications. There are more than we could possibly list. And I think we're going to have 7 or 8 great presenters today who are going to show us how their application solved a network or customer problem and how they began to use it on a standard computing platform and how it got better when they considered an FPGA to accelerate it. So that's where we're at today. That's the setup for our presenters. Along the way, please feel free to ask questions for our presenters. We've got the podium here. We've got you mic'd up. We have a whiteboard. You're more than welcome to jump over there. This is meant to be small, intimate, and interactive along the way, so thank you for your participation, and I'm excited to get started.